Okay, next up we looked at chapter 27, which was our linear regression. I apologize, this does say chi-squared. Again, go ahead and cross that off and change it to linear regression. Linear regression is all of our scatter plot stuff. Your conditions change again since we are looking at two quantitative variables. So here are those conditions, very scatter plot oriented. The first condition is that the scatter plot of your data needs to be linear. So you have to have a scatter plot that's straight. We can't have something crazy curved. The next thing is that your residuals must be independent. So the distance that each data point is from your line of best fit has to be independent from all the other data points. Your residual plot needs to be evenly spread. Usually they will give you the residual plot on the AP test because typically they give you that computer output. So chances are they'll just give you the residual plot. You just have to know that we're looking for that even spread. No clumps or groups should be seen. And then the third condition is that those residuals must be nearly normal. Again, they'll typically give you a histogram, so you just look at the histogram and see if it's nearly normal, or they would give you a normal probability plot, in which case you would check to make sure that it's straight. Now with linear regression, we have two options. We can either make a confidence interval or a hypothesis test. We'll look at confidence intervals first. So my formula for confidence interval is right here. It tells me to take B1, which is the slope, add and subtract t, where t is a t-score, and then multiply by the standard deviation of the slope. Okay, after you've written that down, I do want to point out that this standard deviation of B1, that is just one thing. That is just the standard deviation. So like this whole thing should just be one number. That is just the standard deviation of the slope. On our test this unit, I had a lot of people take the standard deviation, but then also multiply it by the slope again. This B1 is just telling us that we're looking at the standard deviation of the slope versus the standard deviation of the y-intercept, or the standard deviation of the average, standard deviation of the proportion. This is just telling you what standard deviation we are specifically looking at. Okay, if you were asked to create this confidence interval in your calculator, we would first have to have data typed into our L1 and L2. I'm going to change these into, let's do 5, 6, 7, 8. Those all 2s would be pretty boring. It's still going to be boring, but you get the idea. So if I'm making this confidence interval, once I have data in L1 and L2, so I'm going to start there, type data into L1 and L2. Then I'm going to my stat tests. And I'm going to look for a linear regression interval, which should be right here. So that's lin reg t interval. T stands for t-score. We're still using that t-score. Your L1 and L2 should be where you have data. Frequency, you can leave it as 1 or blank. You'd put in your confidence level and then hit enter, and it's going to give you your confidence interval. Mine was perfectly linear, which is why the interval is just 1. Okay, remember that when you're interpreting that interval, we're talking about the slope, so we use kind of the same format as we do for slope when we're writing this interpretation. Okay, so let's go ahead and jot down that interpretation kind of template. We would say I'm 95 or whatever % confident that, now we're talking about slope, so we're going to start writing our slope interpretation, so that for every additional blank, here's where you would put your x variable. We expect the blank, here's your y variable, to increase or decrease depending on the interval. If it's positive, we say increase. If it's negative, we say decrease by an average between blank and blank. So that's where you would put in whatever your interval was. Okay, the next thing we looked at was our computer output. So I'm going to have you just kind of jot down this, makeshift computer output, but it is really important that we know how to read this. So on the computer output, the first thing that they typically give you is the dependent variable. I just have a box there because it's not going to be a number, it's going to be some kind of variable. So it might be test score, anxiety score, fuel economy, some sort of variable there. After that, they typically give you r squared. R squared will just be a number. Sometimes they give it to you as a percentage. Other times they'll give you a decimal. It's technically always a percent though, so usually they'll just say like 67.8%. After r squared, they give you degrees of freedom. And that's kind of the first section of the computer output. The next section then is kind of the most important. You'll know that you're looking at what I consider the most important part of computer output, because at the very top you'll see these headings that say variable, coefficient, standard error of coefficient, and probability. Sometimes they stick in another kind of column in between the standard error and the probability. It might say like t ratio or just t-score. Sometimes it's in there, sometimes it's not. We really don't need it. The main things that we need to be able to find are the variable, coefficient, standard deviation, and probability. So after those headings, you're going to see two rows. The first row is usually the constant. This constant is your y-intercept. So this is giving you all kinds of information about the y-intercept. Under coefficient, this is like the actual y-intercept. So whatever number you have here is the y-intercept. This would be the standard deviation of your y-intercept, and the probability, chances are we will not use that. Next up, I will have just a variable here. This is always going to be your x variable. The dependent variable they gave you was your y. This x variable always corresponds to your slope. So this entire row here is all about slope. So the number under coefficient is your actual slope value. So this is B1. The number next to it, the standard error or standard deviation, this is standard deviation of B1. And then this number here would be the p-value. If you were running a hypothesis test, you might need that p-value. You definitely want to make sure that you know how to read this computer output. They put it on the AP test all the time because it is such an important skill. And they also want to save you time not having you plug in all of this data into your L1 and L2. Chances are they're just going to give you that computer output to kind of negate you using your calculator so much. Hey, if you're running a hypothesis test for this computer output, your two hypotheses are right here. For the null hypothesis, we should assume that the slope, so beta 1, is going to be 0, which means that the two variables we're looking at are not associated. If the slope was 0, it means your scatter plot would just kind of be random and all over the place. Alternatively, we will try and show that B1 is not equal to 0, which means these variables are associated. If you're asked to run a hypothesis test based on the computer output, it should be pretty easy to find your p-value. It would just be right there in the computer output, and you could tell me, after going through phantoms, you would say the p-value is 0.0049, so I reject. If they give you the data and you have to type the data into your calculator, again, you would have to put the data in L1, L2, but then we would go to stat tests. And I'm looking for a linear regression, so a linreg t test. Once I have L1 and L2, I can pick my hypothesis. This hypothesis should always be not equal to. That's what it is every single time for this class. I go to calculate, and it's going to give you your t-score and your p-value.